Okay, now I'm at the HB room of Ritz Carlton residence. Okay, as usual, we're going to check on the installation. Okay, this is their HB room. Okay, this is transformer number 1 feeder, 14% load. Transformer number 2 feeder, 11% load. Calibration not expired yet. This is the incomer, 15% load, equivalent to 35 amp. Okay, here we have a nickel metal hydride tripping unit battery cell, which we call dry cell. 30 volt DC. Okay, charging amp is okay. Rack in, rack out tools in place. Signage, rubber mat, CO2 extinguishing system. Okay, in place, nothing unusual. Earth strip copper tape, earthing is okay. Fire extinguisher in place. Okay, this heater lamp failed. Okay, then we have here. Okay, let's check if the heater okay or not. Okay, we're going to measure the current consumption. Okay, this is the heater switch. This one don't have amp. Then we're going to check on the heater fuse, see whether there's current or not. Okay, there's no current. This one confirm. Either way, the fuse is blown or the heater is faulty. So we have to check further on this. Let's look at the one with the lighted indicator light. Okay. Same. Okay, no amp. Most probably due to old time, most of the heater already be faulty. Another way to really confirm it, there's no heat here. So this brings that the heater is faulty. Yeah, the heater is faulty. Okay, now we're going to have a check on the genset room and the LV room. Then we're going to test run the genset from the LV side at the ATS panel by simulating the signal. Okay, now we are on the way to the Ritz Carlton residence LV room and genset room. This is the genset room. This is the LV room. Okay, let's check power factor value. Okay, see this, is there any tripping? Okay, so far okay, but need to further check the capacitor bank. This is the surge arrestor. Surge arrestor, okay. Okay, about 500 kW. Voltage is okay. Calibration not expired. Okay, this is MSB number 2. Surge arrestor, okay. Okay, voltage is okay. Calibration okay, ACB okay. Power factor above 0.9. Okay, now we go to the genset room. Okay, as usual, before we test run the genset, we will check, is there any leakage? Is the hose okay? Fuel hose? Any water leaking? Radiator water leaking? No. Fuel filter no leaking? Okay. Battery water level okay? No loose termination? Okay, everything in place. Okay, battery termination okay. Let's see. Okay, this one a bit bad, but still okay. Okay, after we check here, this is a fuel hose, no leaking. Okay, engine oil. Okay, engine oil okay. Okay, now we're going to check the radiator water level. Okay, it's that side. So we need to climb up from that side. Air filter, no obstruction. Fan belt okay. No loose. Let's use a torchlight to have a look. Okay, in good condition. Okay. Okay, there's water. Okay. Okay, after check the radiator water level, we'll come back to this panel. Let's check the battery voltage. Oh, battery voltage is down. I don't think it can start. So need to troubleshoot what are the problem. Okay, the reason there's no voltage is because here this voltmeter is faulty, so it's disconnect already. So there's no voltage, but actually after using the voltmeter to measure from the battery side, it's actually 29 volt DC available. So without further delay, we will just test run the genset by simulating the signal from ATS panel. Okay, this is the ATS panel. Jump 4 and 5. Okay, let's use the cable. Okay, between these two terminals. Okay, now the genset is running already. Let's check the genset panel. Okay, after the genset stopped automatically, we found two items is faulty. Okay, first thing is this voltmeter is faulty. Okay, and also this RPM meter is faulty. There's no reading coming up. Okay, the overall the rest is okay. Not much issue. Okay, just now we offload test run. Now we just double check everything okay. SCB on. Emergency stop release. Auto mode. Charger auto. Charger on. Okay, on. Okay. Everything okay? Okay, thank you.